Hi, hello, good morning, everybody. This is Bhaskar. You're watching Bhaskar Time. In this session, we are going to discuss about digital electronics, one of the concept, Kmap simplification method. So, before going for simplification method using Kmap, so what are the different simplification methods are there, and why we need to do the simplification? Okay, let's we take one example here. Okay. So for example, I have one Boolean equations. Let me take one equation here it is. So y is equal to, so let's take y is equal to ab plus, okay. If you go for ab plus a is there. If you want to implement this one, normally we need to implement using basic gates. Let's check it out. How we are going to implement. We have a is one input, b another input. So the relation between ab, it is one AND gate, and next, one more A is there. So relation between this product term and this one, we have a OR gate. So I'll just take it on OR gate here. And this is a Y, what we are getting. If you want to implement this Boolean expression, so normally it's required the two gates now. So it is called two gates. Okay, so two gates it's required that if we use some Boolean expression, so Boolean algebra, some formulas we have, postulates or some theorems are there. With the help of theorems and all, easily we can simplify here. So how? If you take the common factor A in these cases, so A if you take common factor, then B plus 1. And we already know that B plus 1 is equal to, it is 1. And finally, Y is equal to A. Here it is 0 gates we are going to use. Okay, so this way, if you are going to use some postulates, that is 1 plus b is equal to 1. If I use this logic, so completely we have a 0 gates, and here we have a 2 gates. So our main intention it is we need to reduce the number of gates as much as possible. So if you want to reduce the number of gate as much as possible, we need to reduce the number of literals. So for that, we have a different methods we have. First, we need to understand what is the meaning of variables and literals. For example, y is equal to ab plus a bar b plus b bar c. In this expression, variables is nothing but we have a three variables. One it is a, another it is b, and a bar also whatever maybe it is variable it is one only a, b bar and c. Normally it is called variable. We have a three variable. So normally we call it as a variable, and we have a literals. Normally literal is nothing but any variable and its complement also. How many? 1, 2. A bar also one of the literal 1, 2, 3, and B already is there 3, and another what is C. The 1, okay, A, B, 2, 3, 4, and 5. What it is? 5 literal. So if I want to reduce my number of literals, then number of gates it will be reduced. In order to simplify this one, we have a different methods. One of the method here it is Kmap. Normally, so we have a different methods. One it is called, it is a Kmap method. It is called Karnoff map method. Second method what we call here it is a QM method or tabular method. It is called Quine-McCluskey method. Another one it is called MVV method. So in this session, we're going to discuss about Kmap method. Okay, let's move on to the Kmap method. So before going to the Kmap method, we need to understand what is the meaning of SOP and what is the meaning of POS. Okay, let's take it on that. So here it is. If you're looking for any expression, normally the product terms are called, it is a mean terms. Okay, for example, I'll take one expression, it is Y. Okay, Y is equal to I have a AB plus BC. Okay, AB plus BC. Here it is. This normal expression it is called SOP is nothing but sum of the product. So here it is. Here we are what we are doing. This is summation. So what we are doing it is sum, and each one it is called product terms. Is a product, and this is also one of the product. So that's why sum of the product. And one more term we have, it is POS. POS is nothing but product of sum. How we'll get the same expression here? So A plus B dot B plus C. Here what we are doing, it is product of what? Sum terms. This is also sum and this is also, it will be sum. We are doing the product of your sum terms. Okay, so here it is, the product terms, normally it is called mean terms. Okay, so let's take it on that. Here it is, mean term. Another one it is called, okay, max term. So normally mean terms are represented by lowercase of m. Max terms are represented by capital M. And so here it is, each mean terms normally, okay, SOP completely we're going to represent it by capital, sorry, summation. It is a sum we are doing, right? This is for the SOP normally we are going to use. And here we are going to use cap pi for in the POS. Okay, normally it is a sum of it is product terms, nothing but summation of your mean terms, summation of M. Here it is max term. Okay, so it is pi of capital M. Okay, this way we are going to represent it. In any expression, you have a summation, it is related to the SOP, pi is there, it is related to the POS. So mean terms are represented by small m, max terms are represented by capital M. Okay, so I'll take one example for clear explanation. Okay, let's see one. Oh, okay, let's see, y is equal to, same example I'll take, AB plus BC. So in this expression, I have to write mean term equation or SOP form equation. So here it is. First, if you want to write this one, I need to find out missing variable. That is called canonical form representation. Canonical form representation means in the given expression, all three variable or whatever the variables you've taken, all variables should be here. But one variable it is missing here compared to these two product term. One it is missing, that is C. C is missing here. Similarly, A is missing here. So that's why normally y is equal to, so it is nothing but dot 1, right? AB dot 1 or A dot, we already know the postulate, A is dot 1 is equal to what? A. Similarly, here also AB dot 1 also it will be AB only, no changes. So here also 1 is there, but 1 how to write here? A, B missing variable, C plus C bar plus, here it is, what is missing here? A. So A plus A bar, any complement, okay, any variable and its complement we need to take it here, and remaining it is BC. Later, so we need to simplify this one. I'll get a value that is ABC plus AB C bar plus ABC plus A bar BC. Okay, remember in the mean terms, while discussing the previous cases, so mean term condition in SOP condition, 1 means it is true, 0 means it is false. The exactly opposite here, 0 means it is true, 1 means it is false. So how? So real conditions, I'm just taking here. In these cases, a value, it is not complement, right? How to represent it is 1, 1, 1, and here it is 1, 0. Sorry, 1, 1. C value it is C bar is there, so that's what is 0. Next it is 1, 1, 1. Next A bar, it is 0, 1, 1. And we already know that 1, 1, 1 is nothing but 7. Okay, 1, 1, 0, it is 6. Again, it is 7. This one 0, 1, 1 is nothing but 3. While writing the equation, y is equal to, it's a function of a comma b comma c, that is equal to summation of m. The given values are, so you can write 3 comma 6 comma 7. Okay, if they're given this way also same thing, and if they're given normally this way also it will be same thing, and if they're given this way also it will be same thing. You need to simplify and you need to uh, enter the values. Otherwise, normal equation y is equal to, another way also I can write f of a comma b comma c. Here it is summation of it is, so m m3 summation of it is normally, okay, we can write another way also. Normally it is m3 plus m6 plus m7. So here M3 is nothing but what, three variable they're given, right? So 3 is nothing but aram se rakhen 0 double 1 6 1 1 0 7 1 1 1. Again you take the variable, it is a bar b c plus, okay, a b c bar. This is a b c. So all cases it will be same thing only. So this is a SOP representation, this equation, and this way we can represent it. Or normally they're given, you can take the missing variable and canonical form, just represent this one. Same way, if the question is given in POS form, let's take it on that. Okay, I'll just add one more slide. So same question. So previously what we have taken, y is equal to AB plus BC, I'll just taken. Now, in the POS form is nothing but y is equal to product of some terms, nothing but max terms. Okay, okay, duality we can take it on this one. Okay, opposite of this one, how we can take? So A is there. Okay, I'll just take it on A bar. So dot is there, right? It, let's take plus. B is there. It is B bar. And next dot, B is there. B bar. Okay, C is there. Okay, dot is there. Plus C is there. C bar. Nothing but if dot is there, replace it by plus, and plus is there, replace it by dot. Okay, A is there, A bar. So B bar dot B bar plus Z bar. Okay, this way you can take. Otherwise, generally you can take it on this one. This is the expression they are given. So if here also one variable it is missing. So how we are going to miss in the previous cases? C variable we are going to miss it right here in these cases. So you have taken the complement way. Similarly, also here also we can take automatically. So with the help of postulates, directly I can write A bar plus B bar plus C is missing and dot, another way A bar plus B bar. Here we are C we are taken, right. Here we can take it is C bar. Okay, again next missing terms A bar, okay, plus B bar plus C. Another missing term it is A. Here we are taken A bar, right. Next A, remaining should be same thing, B bar plus C. Once you taken, while writing the values, you should know this A bar, B bar, C. Here, bar is nothing but, so you should understand. So here it is 1, it is a bar. 0, it is a true condition. So 0, it is true. 1, it is false. Okay, now A bar is there, right? It is 1. 1, it is 0. But previously 0 means we have taken a complement. Now exactly opposite of this one. Similarly, 1, 1. Here it is 1, 1, 1. And in this cases 1, 1, 0. Okay. So next also here in this cases what I'm going to taken. Okay, sorry. Here it is A bar, B bar, C we are taken. A bar, B bar, C. Okay. A bar, A bar, B bar, C plus A bar, B bar, C bar we are taken. Okay, it's correct. So next again it is 1. Sorry, here it is 0, 1, 0. Okay, again I'm telling, so just take it on value A bar plus B bar. C is missing, C I'm going to take on here, and C bar here. Similarly here, oh, A bar it's missing, here I'm taken, so and B bar and C. Okay, I forgot to take C bar here. Yes, that is a mistake. I'll just take C bar. So C bar we are getting means, so C bar we are getting means, here it is, this is 1 and this is 1, here it is. Okay, so same thing. So how we are getting the previous value, we'll get same thing, but while writing summation of it is pi, we'll write pi of capital M, the value, what is 110, it is 6, again it is 7, this is also 7, this is a 3, same thing, 3 comma 6 comma 7. So previously we also were getting 3 comma 6 comma 7, and here also we'll get 3 comma 6 comma 7. This is another way you can write it out. Here it is capital M3, here it is previously we had taken, it is plus, correct? Because SOP here, capital M is nothing but it is sum terms. So dot we need to write M3, next it is M6, and here it is M7. So this is a y expression what we are getting this. So this way you can write, or this way we can write. Okay, clear? So now any equation they're given. So first we should know what is the meaning of SOP, what is the meaning of POS. Once you understand this one, next we'll go for a simplification using Kmap. Kmap is nothing but turn off map. Okay, so here it is. Intention right now it is clear. I need to reduce the number of variable as much as possible. If you reduce the number of variables, then we can number of gates will be reduced. So that is our main intention. Okay, let's move on to that. So let's take it on Kmap. First, we should know how to write the Kmap. So it's totally depend upon the number of variables. Let's take it on uh, three variables. So first we need to understand, so how many combinations we'll get. So combinations normally we're going to find it off in terms of 2 power. For example, you have a one variable. So if you have one variable means 2 to the power of 1. Nothing but it is 2. For example, one variable, I'll just take it on x. X has a two option, either it is 0 or it is a 1. Similarly, if you have a two variable, if two variable is nothing but 2 to the power of 2. 2 to the power of 2 is nothing but 4. So here let's take the two variable, it is x, y. So combinations, how many combinations? 4 combination. 0, 0, 0, 1, 1, 0, 1, 1. So okay, this is 0 value, this first value, the second value, this is 3 for combination. Similarly, if you have a three variable, so if you have a three variable means it is 2 to the power of 3, nothing but 8. So we need to write x, y, z. Okay, if you don't know how to write this value, easy method it is. Suppose if you have a three variable, so here it is this one. Normally, total it is 8 combination will get right. Out of 8 combination, first four zeros you need to write here. 0, 0, 0, 0. Next four values 1, 2, 3, 4. Next, after 4041, next it is double zero, double one, double zero, double one. Next value it is 0, 1, 0, 1, 0, 1, 0, 1. Actual value of this one it is 0. This value it will be 7. 1, this is 2, this is 3, 4, 5, 6, and 7. Okay, this way combinations will get. Similarly, four variable means, so four variable if you take a w, x, y, z. So 2 to the power of 4. 4 is nothing but 16. Minimum value is 0, 0, 0, 0. Maximum value is 1, 1, 1, 1. So 8 zeros and 8 ones. Next 4 zeros, 4, 1 for x, y, double 0, double 1 continuously. Next 0, 0, 1. So each value acts as 0 to 15. So each one 0, 1 1 value, it will be 1 1 value. So it will be 0 and this value become it is 15. Okay. This way we need to write the combinations. So once you write this, so while writing the K map, okay, so I'll just show one few example. Let me take one PDF I prepared already. Yes. Yeah, in this case, you see Kmap representation, how we are going to take it on this. First, I have a two variable here. It is A, B, only two variables. So two variables I'm going to take it is if they're given. So A variable I'm just take it here. B it is another one. So normally total number of cells we need to find out how many cells will get it out. So 2 power of 2 is nothing but we'll get 4. 4 cells will get. How to write the values? Normally two variable Kmap is nothing but sorry, two variable is nothing but either it is 0 0 0 1 1 0 or 1 1, right? Now how I'm getting, okay, if we take the variable, it is this is A, this is B. Let's take it down. First it is A, B, 0 0 condition. Normally A, B given means 0 0. So we are going to fill the value, it is M0, mean term 0. Next is 0 1, it is M1. 1 0, it is M2. 1 1, it is M3. So why we are going to use M here? Mean terms or a product terms. Okay, so if it is three variable Kmap means one variable I'll just take it on here, remaining two variables here. Okay, now in this case, A you see, you have a 0 and 1, two option, right? Take go individually. A is nothing but one variable, two option. Either maybe it is 0, it is a 1. So BC, it's a two variable. Two variable is nothing but it is 0 0 or 0 1 or 1 0 or 1 1. But while writing, we're not writing it is a 0 0 or 0 1 or 1 0 or 1 1. because so here I need to take in the Kmap common terms, we need to take it out. But if I follow this way, see if I go for 0 0 and 0 1, one value it is fixed now 0 0, this value it is varying, but next value after 0 1, if you go 1 0, so 1 to 0 also changing and 0 to 1 also it is changing. I don't want this. I can't take any common factor, so that's why what we need to do, instead of taking 1 0, after 0 1 we are taking 1 1, next it is 1 0. In these cases this one it is fixed and this bit it is changing. In next cases and this is fixed and this bit is changing. So this sequence it is called gray code sequence. You can see this sequence it is called gray code sequence. Either it is a 3 variable or 4 variable. We are going to use same thing. Next, how to fill these values? Okay, here it is 0 0. Next value it will be. Okay, let me uh, change the color. Okay. Okay, so 0 0. Next value it will be. Sorry. Okay, 0 0, next value it will be 0 1, next is 1 0, next it is one, sorry 1 1 and 1 0. We are going to take on. So here also you can observe this. The four variable came up means carefully observe this. Here it is we have a 0 0, next it is 0 1, 1 1 and 1 0. Here also 0 0, 0 1, 1 1, 1 0. Here I'll take the two variables here A B, and here I'll take a C D, four variables. And while writing the cell positions, you see that here it is not an issue. 0 1 2 3 we are going to write, but here this is 0 1. Next you need to write this one, last one 2, because while writing you see 0, last one it is 1 0, right? So 0 1 0, nothing but 2. Okay, next 4 1 0 0, it is 4. Next it is 5 1 0 1. Next it is 7. Okay, 1 1 1 will come because it is, this is 1 1, this is 0 0, this is 0 1. Now you take any value, so 1 1 1, it is 7, so that's what is M7. And here while filling also, first you fill this, next this one, next 2 3, next 4 5 6 7, 8 9 10 11 12 13 14 15. So this way you need to write the Kmap. First task it is, if they're given any expression or any mean term equation or SOP expression, you just find out number of mean terms, so number of variables. Based on the number of variables, the first task you need to write the Kmap. Okay, so once you write the Kmap, the next task it is you need to simplify. Okay, here they are given one example, you can observe this. They're given on truth table. The values here it is, you just observe a value it is 0, b value it is 0, y value it is 0. That's why a it is 0, b value it is 0. Just in these cases, we're filling the values, representation of truth table onto the K map. The 0 value I'm just filling here. Next it is 1 is there, right? A value it is 0, b value it is 1, means this one. This value we're filling here. First here, next it is 1, next it is 0. Okay, so and 0 is nothing but here you can, it is another way also you can represent it here. 0 means it is A bar, 1 means it is A. Okay, here also variable it is B, it is B bar, and next it is 1, it is B. Similarly, okay, here in this case 3 variables are there. You observe this, 3 variables. And outputs just on truth table we are getting it is this way, 0 1 1. So in these cases, first you split the 4 values, 1 2 3 4. Yeah, this is the 4 values. Fill this one, how? 0 0 1 0. While filling 0 0, you fill last one, 1 0. Don't copy paste as it is, because cell position 0 1 2 3. Next double 1 0 1. So double 1, here it is 0, next it is 1, you need to fill it out. Similarly, um, another way, so this you can take it as 0 0 or 0 1 1 1. This is just I'm talking about the representation. Another way how I can represent, a value to 0, right? A bar and A, B bar C bar, B bar C, BC and BC bar, nothing but 0 0. It's just I'm applying 0 0. This is 0 1, this is 1 1 1 0. This way you can represent. Similarly, 4 variable also is there, 4 variable well represented. So that is the cases, first 4 values. So 1 2 3 4. Okay, 1 0 0 1. First see 1, okay, 0 0 and 1. Next 4 values. Okay, 1 1 0 1, 1 1 0 1. Next it is 0 0 1 0. Now don't fill this one because 1 0 it is starting from here, right? 0 0 1 0, and last one it is 1 0 1 1. Just we are filling this one. So 1 0 1 1 we are filling. Okay, so this way, if any truth table they're given, just you need to fill it out. So sometime what they will do, okay, ah, so same equations. For example, let's take it on this equation. So truth table they're given. Otherwise, they are given summation equation, summation of m. So where true conditions are there, you see this is a second one. It is true, means high. One is there, so 4. Next it is 5. 7. So 2, 4, 5, 7. Okay. 2, comma, 4, comma, 5, comma, 7. If they're given, also same representation. 2 second cell, we are going to make it high. 4 cell, we are going to make it as high. Fifth cell, we are going to make it high. And 7 cell also make it 1. Remaining values, we are going to make it as 0. Okay. So 1 minute. Let's. Okay. So next, once you understand how we're going to enter into the Kmap, next process here it is, we need to simplify that. So next process, before going to the simplification, first thing it is, we need to find out the adjacent cell. So what are the adjacent cells in these cases? You just observe this. So neighbor cells in the row are adjacents. So this is normally looking for the first column, second column, third and fourth. First column and second column, it's called adjacent. Similarly, second and third also called adjacent. Third and fourth also we call adjacents. Okay, but not second and fourth we call it adjacent. Okay, so this way you need to find out row wise or column wise. Here column wise we are doing, and these two are adjacent and these two are adjacent, these two are adjacent, not this one and this one. Okay, we need to identify adjacent ones where you have. Similarly, top and bottom also, left and right also. See first one and one, two, three. Okay, one, two, three, four. So this way, these two are called adjacent because if you fold the paper, so these two I can take easily. I can take the common factor. First column and the last column also adjacent, and first row and the last row also we call it is adjacent, are also called top and bottom also. So this way you should identify the adjacent cell. Next, once you identify the adjacent cell, see always we need to do the grouping of in terms of 2 power. Okay, for example, in my Kmap, it is a 16 cells is there means. So first, is it possible to group 16 cells? We need to try. Okay, because 2 to the power of 4 it is 16. Maximum cells it is possible. If no means, then 2 power of 3. 8 cell only we can do the grouping. It is not possible, then we need to looking for 2 power of 2, 4 grouping. So that is also not possible means 2 to the power of 1, 2 grouping. That is also not possible, then 2 power of 0, it is 1. So I can do single grouping, 2 grouping, 4, 8, 16 cells easily we can involve in the grouping process, not 3, 5 and all the things. Okay, so how to do all the things? Let's take it on some example. See, first condition it is always we need to target for the maximum grouping, because maximum grouping is there, then we can reduce the number of literals as much as possible. With the help of an example, I'll explain that. Just come. Okay, so here we are just explain about the two adjacent ones grouping and all the things. In this case, you observe this. Okay. The values just I'm going to enter here. It is normally one is there. So these two, this column and this column both are adjacent, right? The values if you write anyway 0 1 or 1 1 also you can write. Otherwise normally B bar C and BC is there. What is the common? The C is common. Here also you see C between these two we have a C common. So I'll write C first, and it is involved in only one row, that is A bar. So that's why writing A bar C. Suppose same thing if it is coming, because here only one row means that row variable we are going to write here. Similarly, in this case, you see B, C, because it is not shared by any other column. It is we have only one column, then we need to write here BC directly. The output of this one it is grouping BC only will get it out. But row wise I can't take anything because I am not able to get any variable, because here it is a bar a. Okay, here suppose in this way b bar c bar b bar c is there, b bar I can take common factor, but in this case I can't take, right? So if there is no common, then we need to neglect the variables. I'm neglecting this variable. I'll write this one directly. That's why I'm getting bc. And if you use a formula and simplify also, we're getting same thing. So we are using some formula here. What we done, we have taken a bar c and a bar c common factors. So how we are getting a bar c here, a bar b bar c here? This is a representation only. How to represent this one? Here a bar, and this column it is b bar c, a bar b bar c, and this representation a bar b c. Okay, so this is related to this a bar b c, a bar and b bar c. So that expression if you simplify using so boolean postulates also, you'll get same thing. So I'll take a bar c common factor, remaining b plus b bar, I'll get a bar c. So this is another method with the help of Kmap we are simplifying. Okay, similarly another example you see. Suppose here 1 1 is there. How to simplify? So you just observe the first column and the last column. So in these cases, it's common to come which one? C B bar C bar and B C bar. Common it is C bar. So that's why we'll write here it is C bar. Okay, I'll write. So from these cases, I'll write it is C bar. But and column only one row you have, right? A value is there. If two value it is sharing means you need to neglect that variable. But you have only one row or one column. Let write only one variable, it is A. So I'll write A C bar. Similarly, in this case, you observe this the four variable Kmap we have. So here in these cases, we have only one column. In the one column, we have a C bar D. So I need to write the expression, it is C bar D, it is common. No need to change anything. Then you observe the first row and the last row. The first row and last row, if you observe that, so here it is common term A bar B bar and AB bar. B bar it is common. Okay, that's why we'll write B bar here it is. B bar, C bar, D. Okay, similarly, looking for some other example. So groups may overlap. You see, in this example, so dual will do. Okay, these two if I do, we already done, I get a bar C. Suppose if I do individually, single grouping, because in these cases only three ones are there. Okay, here single grouping is that if I do this one, what is the expression we'll get? You see, I'll get A, B, C. Three variables are there. If three variables are nothing but, three literals nothing but, so it require a one gate extra. Okay, normally if you're looking for two input AND gate you're using means two AND gates I need to use. So number of literals we need to reduce as much as possible. So groups may overlap. So in these cases, in the same level, it is not possible. Okay, if you have an option for two or one, groups may overlap for the higher grouping. So in these cases, you can group with this one and you can do this one. Okay, then if you go group this, will not get a variable, only bc only will get it out. So answer it is a bar c and another group. So if groups are separating, two groupings are there, a bar c plus we are putting another grouping bc, separation it will be plus. Similarly in this case you see you have an option, sir. A bar c you already having this, and next you already have one. Sir, you already explained this one, you are grouping with this one only to do, so this one I'm doing. No. So groups overlapping in the same level, if it is required, you have to do. See here, this one compared to this grouping and this grouping with this one compared to these two, highest priority to give it to this one. Otherwise, if you do the grouping, then this is alone only, right? Definitely need to do this grouping, and this is waste now. So in the two dual only we are doing. So then what I need to do? So highest priority we need to give it to this one only, and this grouping and this group. If you do this way, a value is there, common it is b value, I'll get ab. Then if you want, you can take pair, but if you simplified also, it is not that much affected that. So groups may overlap if it is required. That is a condition is there. You need to follow that one. If it is same level, okay, for example, dual only you're doing means two grouping only you're doing means first without overlapping you need to try. This is what we done. Without overlapping, it is possible. We need to give highest priority. Then without, okay, if with the with overlapping, if it is suppose four is there, for example, in this case you have a one here. That time it will come quad. Okay, that time you can do this completely quad. You can do that. Okay, in these cases it is not possible. Then directly I need to write this way. Okay, next. That is a two groupings. So next three grouping or four so not three, four grouping. Four grouping you see. Okay, three variable map, all one ones is there, right? Directly, completely it is one. So column wise, I can't take any common factor. So that's why we are neglecting this variable, directly one variable A. Answer it is A. In this case, one column completely is there. So row wise, I can't take any common because A bar, B bar, because 0, 1, I can't take any common factor. Need to neglect this variable. And answer it is CD. Directly we can take it on. And next, if in between is there. So in this case, observe carefully. You have a two rows and here it is two columns. So what is the common between here? A bar B and AB. B is common. Just take it on B. So here just take it on B out and column wise C bar D and CD. I'll just take it on D. Answer it is BD. Directly we can take it out. In this case, you observe this. So first row and last row also I call it as a common. Means we can adjacent. Now you can see AB, AB bar, common I can take it is A. And in this case, C bar, D bar. Here it is C, D bar. Common term it is D bar. So answer it is A here common. Okay. And from this one, D bar it is common. I'll get AD bar. Okay. So next it is corner grouping also it is possible. You see this corner and this corner, this corner, this corner. Sir, what you will do, what is the mistake you will do? Okay, you will do the single grouping of this one. Any corner is there? No, it's possible. See, first one, last one. What is the common? A bar, B bar, A, B bar, B bar. Common it is B bar. Easily I can take. So I'll get it is B bar. And first row and last row. First column, last column. C bar, D bar, C, D bar. Okay, common it is D bar. So B bar and D bar. Answer. Okay, in this case, you observe this. So quad is there. So here I'll just go for the quad completely. Column wise, I can take anything. So answer it is AB. We'll write AB. Next, you see groups may overlap. So this grouping I'll do. But next one is there, right? So don't go for groups may overlap for the maximum grouping. Intention right now it is clear. I'll go for the maximum grouping. Okay, I'll go with this one and groups again it is overlapping. So common term between here and here it is CD and D bar. So I'll take it C as common factor between here and here D as common factor. So it is common AD plus AC both will get it out. Okay. So, and next eight grouping. So eight grouping is nothing but so completely column wise I can take anything. So here and here what is the common? Previously four grouping means I'll write AB. Now in this case common we take B. So I'll get B here. Similarly, a complete column. This is a row wise. This is a completely column wise. What is the common? It is D. Okay, row wise I can't take anything. Common terms. So column wise I'll take C bar D and D. I'll get D here. Okay. Next, first row and last row. If you take in these cases A bar, B bar, A B bar, and B bar is common. So I'll write B bar. And in this case, first column and the last column you see. So row wise I can't take anything. So common it is D bar, D bar it is common. So that's why Y is equal to D bar. Okay, this way we can do dual, quad, and this is 8 is nothing but octa grouping process. So after that, you need to simplify and get the equations. So illegal groupings, this is not possible. Three grouping, it is not possible. See, for example, you have a three between here. If I do this one, how I'm going to take the common factor? It is not possible. And diagonal grouping also, it is not possible. See, this is diagonal grouping normally. I can't take common factor. Diagonal grouping, it is not possible. So three grouping, it is not audible. Normally, grouping of odd number cells are illegals. It is not possible. Okay, so this is a uh, representation of Kmap and simplification and grouping process. Okay, so in this session we discussed about this one. In the next session we want to take some examples of SOP and POS and how we need to simplify. Okay, thank you.